Welcome to MENG 4313, section 031. We are covering pressure transducers, and we are group 8. I am Sergio Hernandez.
Steve Strahan.
Van Burnett.
Milot Seamus.
Samuel Morales.
Michael Geddes.
Group 8 be covering the following topics. What is a pressure transducer? How it works. Electrical devices in transducers. Types of transducers. Temperature and its importance. Pressure spikes. External sources of errors in pressure transducers. Internal sources of errors in pressure transducers. Pressure transducers applications. And the specifications. What is a pressure transducer? A pressure transducer converts an applied pressure into an electrical circuit. It produces an electrical output signal into voltage, current, and frequency proportional to the pressure. It is designed to produce an output that is linear with applied pressure and independent of the system variable. It is made up of two parts, an elastic material and an electrical part. The most common pressure transducer is a strain gauge, as shown in Figure 2. A pressure transducer is also known as a transmitter.
How does a pressure transducer work? A pressure transducer converts pressure into electrical output signal, such as voltage, current, and frequency. The sensor in the transducer allows the transducer to proportionally react to the applied force of the pressure. Majority of pressure transducers operate using electrical input and responsive to change in both pressure and temperature. The electrical devices in transducers. The most common configuration of the elastic material in the transducer is the diaphragm. 3 different types of electrical devices can be attached to the diaphragm to create an electrical signal. First being a resistive transducer, which uses a strain gauge. The strain gauge is bonded to the deformable material, and any change in the deformation causes a change in the electrical resistance of each strain gauge, which can be measured by a Wheatstone bridge. Second would be a capacitance transducer, which uses a capacitor and capacitance plates. Change in pressure is measured change in capacitance between 2 capacitance plates. One plate is bonded to the deformable side of the elastic material, or the diaphragm, while the other one is bonded to the unpressurized surface. Third being the inductive transducer, which contains a ferromagnetic core. The deformation of the elastic material is used to provide the linear movement of the ferromagnetic core. This linear movement will vary the induced AC current. The signal in each type of device usually has a linear relationship with the displacement of the diaphragm. Other types of transducers, including what's already been mentioned, the diaphragm, board-on tubes, bellows, and capsule.
Pressure transducers are used in any fluid power application requiring a high resolution and accurate electronic measurement of pressure. Used for closed-loop pump control, can make a fixed displacement pump behave like a variable displacement pump. Can also be used as electronic variable pressure switch. Can also take the form of a self-contained control unit, such as a programmable digital pressure switch, are used to measure the pressure of this specific quantity, like a gas or liquid, by changing the pressure into electrical energy. The applications of pressure transducers mainly involved in altitude sensing, pressure sensing, level or depth sensing, flow sensing, and leak testing. Temperature is a major consideration in the performance of a pressure transducer. Pressure transducers are specified to have a compensated temperature range and an operating temperature range. If the transmitter housing temperature falls outside this range, the output signal may show an extreme drift, or the transmitter may stop operating altogether. Even relatively brief exposure to temperatures outside the specific range can lead to permanent damage. The median temperature directly impacts the overall performance and accuracy of the pressure sensor readings. It is important to remember that the temperature compensation circuit is mounted inside the body of the sensor. Therefore, to ensure proper compensation, the complete font assembly of the sensor must be heated or cooled. If the sensor is subjected to a heat shock, either via the pressure media or from the surrounding environment, large errors are possible that can exceed the specifications.
So I'm Sam, and we're going to talk about pressure spikes. Some causes of overpressure include unintentional heat applied to the system. So say, for instance, the system itself is being overused, or there's something surrounding it that's causing the temperatures to rise. That could cause a failure. There's also faulty pressure regulator case where upstream there's a regulator that could fail, and that caused the sensor or transducer downstream to fail because it's experiencing above pressure that it's rated. And there's also fluid hammering, which is a case where if you look below, the water or whatever fluid it may be is abruptly stopped, and it's because the valve is shut or whatever the case may be, and say the sensor or transducer is located before that, it could cause that sensor or transducer to experience a hammering effect, basically damaging it. To the right, we have effects of overpressure. So that means damaged or inaccurate pressure transducer that could be caused where the diaphragm seal and or gasket is damaged. So if you look in the center picture, this is what it would look like, a typical picture of a transducer, where this seal is the thing that is protecting the transducer itself. And if the gasket or anything is damaged, it's basically ruined. It could also cause, like I said, potential failure of downstream components. So anything downstream from the transducer itself could be harmed, and also costly fixes. So look to the right corner, we have just a scenario where things have been damaged by where we talked about fluid hammering or such things like that. This could be a potential case, so not good.
Next, let's talk about external sources of error in pressure transducers. The sources of error include extreme temperature fluctuations, power supply issues, electromagnetic interference, and test setup and conditions. These errors can affect the pressure transducer based on where and how it is implemented. If the transducer is subject to extreme temperature fluctuations, this may change its output signal even though the pressure and other factors remain constant. Even with high accuracy pressure transducers, the errors can be quite significant with changes in temperature. Using a pressure transducer with inadequate power supply or running near the minimum supply voltage can sometimes lead to problems, especially if there is an additional load resistance in series with the sensor. Sources of electrical interference may affect the signal's output, mainly due to improper shielding of the solid-state components inside the sensor. Finally, if factors such as moving parts, heat sources, or any other factors that could cause a pressure reading to fluctuate aren't taken into account with the testing setup, poor pressure transducer performance can be expected. In addition, improper wiring connections and poor electrical contacts could lead to fluctuations in output signal. In addition to external sources, there are also internal sources of error in pressure transducers. These errors can be attributed to the sensor's mechanical design, sensitivity, offset, and response time characteristics.
Pressure transducers can be used for different applications. For example, off-highway vehicles, natural gas equipment, semiconductor processing, power plant, refrigeration, robotics, test and measurement, barometric, HVAC, transportation, and medical devices.
This pressure transducer is used for power plant.
The following are specifications for pressure transducers.